Hi guys, welcome back to my channel. We're actually working on this question and we have two equally charged spheres. Sorry, they're not equally charged, they're actually of the equal mass. So this is 3.7 gram, which is the same thing as this in kilograms. So this is mass 1, this is mass 2. The first one is charged at Q1 to be 1 times 10 to the negative 7 coulomb, and this one is charged to be 5 times 10 to the negative 7 coulomb. So this is 5 times more charged as the other one. The tension in the rope here is the same. They are separated by a distance of 16 centimeter or 0.16 meters, and they're both positively charged, so they're actually repelling in this case. What we're trying to figure out is to find the angles for both of these spheres, meaning, so if there was a vertical here, this would be called theta 1 and this would be called theta 2, and we're trying to find out the deflection angle from the vertical. Okay, so in order to start this, first thing first is a free body diagram on both spheres. So on the first one, I have the tension going this way, and if this is T1, therefore by parallel lines, this line is parallel to this one would be theta 1 as well. So my angle would be here. I have mg down, and I have Fe, which is the electrical force acted on M1 by M2 going in the opposite direction. Now on my second sphere, I will have the same thing. I will have mg here, and I'm just not going to mark the m as m1 and m2 since they both have the equal mass, and the tension is going in the opposite direction here, and it makes an angle of theta 2 with the vertical. Also, I have the electrical force going in the opposite direction. Okay, now one point that one thing I want to point out here is that electrical force in this case is equal to K Q1 Q2 over R squared. And if I were to write the values for the first one and the second one, I realize that this F1 here and this F1 here are equal in magnitude and opposite in direction. And I know that because I will have to write K, Q1 is 1.7, and then Q2 is the same for both cases, and the distance between them is always 16 centimeters. So if I write Fe for the first charge and write it for the second charge, I will find out I will get the same number since none of these values are going to be different in both cases. Okay, now that I know that, then I will know that my theta 1 also will equal to theta 2. Since they're both deflected by the same thing, the mg's are going to be equal, and since mg's are force of gravities are equal and Fe's are equal, therefore the tension will be equal and theta 1 and theta 2 will be equal. Now the only thing we have to prove in this case is to find out what the actual theta 1 is measured to be. So therefore I can choose to work with one of the masses only over here, and I'm just going to write my forces in the x direction. So sum of all of my forces in the x direction is equal to mass of the sphere times the acceleration of the sphere. And since my acceleration is not, since my sphere is not moving in the x direction, this is going to be equal to 0. So sum of all my forces is equal to 0. Now let's see what forces I have here in the x direction. So I have my tension, and the x component of my tension force, which I'm going to actually show in a different color, so let's use blue, it's this dashed blue, actually this blue line. And since it's opposite to the theta, it would equal to t sine theta. If you have any questions regarding how I got that, please comment it down below and I will get back to you. Now going back to my equation, I will write t sine theta, and it would have a positive sign since it's in the positive direction. Obviously, I'm going to get this to be positive and up to be positive as well. Okay, now my force, electric force is going to be in the negative direction, and that's going to equal to 0. Therefore, my electric force is going to equal to t sine theta 1. Well, theta 1 and theta 2 are equal, so I'm just going to use theta. Okay, so that's one of my equations. Now in this case, I don't know what theta is, and I don't know what t is. Therefore, I have one equation and two unknowns. Therefore, I know that I can't solve this. I need another equation, so I'm going to use my y direction. I'm going to write the same thing. Since I'm not moving in the y direction, sum of all of my forces in the y is equal to 0. What are the forces that I have? I have my t cosine of theta in the positive direction minus mg equal to 0. Therefore, t cos theta is equal to Fe. Right? So in this case, I don't know what t is, and I also don't know what theta is. So I also have one equation, two unknowns, but conveniently, it's the same unknowns that I have in the x direction part. So I'm just going to clean this up a little bit and write them all together. So I have Fe equals t sine theta from the x direction, and I also have, I forgot, Fe equals t cos theta. So Fe, not Fe, sorry. This is equals to mg. So go back, and then I will have mg equals t cos theta. Okay, now since I have two equations and two unknowns here, I can actually use the method of elimination to solve this, and very easily. So I want to get rid of the t, since the question is asking for theta, so it would be very convenient if I could do that. Now let's take a look. If I could divide the first equation by the second equation, I would get rid of the t, and I will end up with only tan of theta, which is very convenient, equal to Fe over mg, which is perfect. Now what we're looking for is theta, so for Fe I have k q1 q2 over r squared divided by mg. Now in order to simplify this, I have mg over 1, I multiply this by this, divided by that, so kq1 q2 times 1 over mg r squared. That's it. So pretty much tangent of theta is equal to that. So if I find this in my calculator, since I have all of these values known to me in this question, and take the inverse tan of it, I will get the angle. Okay, so I can actually plug everything in. So tan of theta is equal to 9 times 10 to the power of 9, 1 times 10 to the negative 7, 5 times 10 to the negative 7, 0.16 to the 2, 3.7 times 10 to the 3 kilogram, and 9.8 for G. And then theta is equal tan inverse of that. If I enter that into my calculator, theta will be equal to 25.6 degrees. And since theta 1 is equal to theta 2, they're both equal to that. Alright, if you have any questions, please comment them down below. Thank you for watching. Bye-bye.